And so this is x of t equals e raised to power 2t, and then you're multiplying with the difference of unit steps, right? So what about e raised to power 2t? Is if I were to plot e raised to power 2t, that's just what kind of an exponential is it? Kyutala?
Uh, it's an exponential. Raised to
Exponential,
power
I
2.
mean, decaying exponential, or
Growth. Yeah, growth. It's an exponential growth.
it's a growing exponential, good, right? So it's a growing exponential, right? Something which looks like this, right? Like an asal test jo tha, that was कि what does this stand for? What does this look like? So this is step unit u of minus 2 minus t minus u of 1 minus t, right? So ye, what kind of a signal would this look like? So I can plot these one by one, right? So let's see, Kiji, what is u of minus t minus minus 2 minus t? Um, so this turns out, Kiji, this is, if this is t, this is a unit step in the opposite direction, right? And where this is minus 2, right? Do I need to explain k why is, does this start from minus 2 and goes all the way back to minus infinity? Now the एक तरीका कार इसका ये है कि जी you do the flipping and shifting and you do all of that. But I mean, when I do this, I typically use an easier way of doing this, which is the following way. I know that u of t is equal to 1 for t is greater than 0 and is equal to 0 for t is less than 0, right? So this implies that u of minus 2 minus t is going to be equal to 1 for t is for minus 2 minus t is greater than 0 and is going to be 0 from minus 2 minus t is less than 0. And the first condition here would imply that this t is less than minus 2. And the second condition implies that t is greater than minus 2. And this clearly is what this signal is. Okay? So instead of doing the flipping and shifting that we're comfortable with or we're familiar with, and of course you can do it that way, but I typically just plug in the conditions and then see कि यार ये left side पे है या right side पे है, और अगर left side पे है तो where does it start and where does it go to? ठीक है? Any questions about what I've done here with this green thing here? I'm going to erase it now. Okay. So going by the same arguments, I mean, if this is u of minus 2 minus t, what would u of 1 minus t be? क्यों जी? Manur, can you try to guess or not guess,
Um,
determine?
yes. Um, so अगर हम उसी same logic से apply करें,
Yeah.
फिर 1 minus t is greater than 0, तो फिर हो जाएगा t is less than minus 1, और फिर 1 minus t is less than 0 के लिए वो हो
Yeah.
जाएगा t is greater than minus 1.
No. So you're going by the same logic, right? So u of 1 minus t जो है, u of 1 minus t is going to be equal to 1 for 1
ठीक
minus t is
है,
greater than 0, right? So this
सही
means this is t is less than 1
less than 1,
and
सही
0 otherwise. ठीक है, तो I just need to just check the first condition यार कि when is this going to be equal to 1? This is going to be equal to 1 when t is less than 1. Okay, so by using the
सही
same arguments, Manu,
-1 ही होना था.
no, so it's plus 1. देखिए
Okay.
u of 1 minus t is equal to 1 for 1 minus t is greater than 0, right? And 1 minus t is when is this greater than 0? This implies that t is less than 1. Right, this goes there. So x positive 1 रह गया, right?
सही. Oh, I get it. सही.
And
Thank you.
Manu, यहाँ पे देखें, यहाँ पे भी there's a difference here and here, right? I mean, here was -2, this was +1. So I mean, this
जी
also tells you कि यार वो should not be -1 here, right? Should not start from -1, right? So it starts at +1. and goes actually some starts at minus infinity and goes all the way up to, sorry, so यहाँ पे +1 से start होता है और goes all the way back to minus infinity. This is a subtraction, right? So what do you get when you subtract these two signals?
A step from 1 to -2.
1 to -2. But what, I mean, is it in the positive direction or the negative direction? You see, you're subtracting this signal from this signal, right? So as you rightly pointed out, Kitty, it's going to be something between -2 and +1, right? But between -2 and +1, it is going to be -1. So this is +1 and this is -2, and here is going to be 0 and here is going to be 0. So everybody gets, okay, why is this -1? And the height is -1. Manu, do you get that?
Yes, sir, because it's in the negative y direction.
Exactly, right? So I'm subtracting this right signal from the left signal. So that's why it's negative. Okay? And then ultimately what you're sketching is these two signals multiplied together, right? So what does that give you? That gives you, if this is the x-axis, right? The signal that you get is going to be equal to 0 for all t is less than -2. And then it's going to looks like this, and then goes back and then stays 0, right? And then you can figure out, yeah, or ye, this is time t equals 0. Okay, this is time t equals +1, this is time t equals -2, and what value will this have here? This will be e raised to power -2t, right? And actually -4t. Oops. -4t, and this height here is going to be equal to e raised to power 2t, right? So this is a sketch of what x of t looks like. Any questions here before I move ahead? Okay.
So, how did you figure, like, आपने यहाँ पे इसको इन्वेस्ट किस तरह किया, like on the negative side, the axis पे?
Okay, because I'm multiplying this signal number 1 by signal number 2.
हाँ, लेकिन just जब आप माइनस कर रहे थे -2 in unit step, जब आपने उसको like on y axis कैसे इन्वर्ट किया, क्यों किया है? From what you have written.
Signal number 2 ko?
Yeah, signal number 2 को.
That is because signal number 2 is equal to this signal A minus signal B, right? So what do you get when you subtract signal number B from signal number A?
So सिर्फ उसका मिडवे या पार्ट -2 से 1 या पार्ट बचना चाहिए.
Right, you see, देखें आप जो है ये subtract करें, right? So that means के this is signal number A, which is from minus infinity all the way up to -2. ठीक है? इसमें से subtract करना आपने signal number B, right? Signal number B, when you subtract it, let me just multiply that with -1 and see के what do I get. So this will be signal.
ठीक है.
This will be signal number.
Yeah, I remember it. मैंने actually ये step मैंने पेपर में खुद किया था सारे ये step, and I was just figuring out कि आपने directly कैसे किया.
Right. So ये if I add green plus red, what do I get? ये वाली सारी चीजें कैंसिल हो जाती हैं, ठीक है, और जो है ये चीज -1 होती है,
ठीक है,
और बाकी हर जगह पे 0 रह जाता है.
या ठीक है,
ठीक है, is that clear?
या ठीक है, थैंक यू.
Okay. देखिए, so I mean, let me just, if there's something you don't understand, ask me now. I mean, better to ask here.
I get it. मैंने पेपर में भी इसी तरह किया था.
आपको नहीं कह रहा, मैं in general कह रहा हूँ, sorry, right, तला? Right, so if you have any doubts, just feel free to, without any hesitation, बगैर किसी शर्म के, मैं शर्मो हया कहने लगा था, लेकिन जो है सो आई तो फिगर्ड कि हया इज नॉट द राइट वर्ड हियर. सो बगैर किसी शर्म के जस्ट गो अहेड एंड आस्क. ओके, ऑलराइट. Anybody else who has a question on how I got this? All right. Okay, so this is now part B, right? So part B may, let's try to sketch x of t. So I had points reserved for this, by the way, right? So if I sketch x of t, what would it look like? कौन हेल्प करेगा? हमजा? Hamza Rashid?
Yes, sir.
I mean, can you help?
सर कौन सा वाला पार्ट आप कह रहे हैं, सारा एक साथ कह रहे हैं
नहीं,
या?
सारा एक साथ नहीं. Just tell me कि x of t, what would it look like? I mean, if I were to sketch x of t, how would I sketch this?
सर पहले तो u of t हम सिंपली बनाएंगे.
Yeah.
और सर फिर उसका u of t minus 1 और इनको सब्ट्रैक्ट कर देंगे.
तो इनको सब्ट्रैक्ट अगर मैं करूं तो क्या निकलता है? If I subtract u of t minus 1 from u of t.
सर 0 से स्टार्ट होगा और 1 तक जाएगा हमारा ये.
गुड, एक्सीलेंट, राइट. सो 0 स्टार्ट्स और 1 तक जाएगा, और इसकी हाइट क्या रहेगी? हाइट 1 होगी,
1 ही रहेगी.
राइट. एंड इफ आई मल्टीप्लाई दिस विद t, फिर क्या स्केच होगा?
सर फिर सर वो ट्रायंगल सर बन जाएगा 0 से 1 तक.
So t is just a ramp, right? I mean, with a slope 1.
जी सर.
So when you multiply them together, so what you're going to get is something like this. Is a ramp and then goes back. So this is 0, this is 1, and the height here is 1. Okay? So this is signal x of t. This is x of t. So what about y of t? Now y of t has two kinds of operations. One of them is compression. One of them is expansion, and the other one is shifting. You could do either one of those first, right? Let me just try to do this in steps, right? So I can say, let z of t be just equal to x of t minus 3, right? Then y of t, it turns out, is actually equal to z of t by 2, which by verification, indeed, I can figure out, yeah, this is x of t2 minus 3, right? So this is two operations. So step 1 is shifting right by 3 seconds, and step 2 is compression on the resultant signal from step 1. Actually, sorry, expansion by a factor of 2, right? So these are the two steps that we have, right? So z of t looks like this. So this is t, and z of t is starts at 0, and then actually starts at 3 and ends at 4 and stays 0, right? So this is z of t. And y of t is just the expanded version of z of t. So this is t, and z of t would be starting at 6 and ending at 8. और इसकी हाइट क्या होगी? क्यों जैन, हाइट क्या होगी?
जी सर.
इसकी हाइट क्या होनी चाहिए?
सर अभी हमने उसको वो अभी हाफ नहीं किया ना, उसको
कर दिया हाफ.
तो
6 और 8 हो गया ना हाफ.
सर हाइट उसकी फिर भी उतनी होगी सर, वो तो उतनी होगी जितनी वहाँ पे
Exactly.
थी.
Good. Excellent. It will stay 1. Thank you, Asad. That's correct. Right? The height just stays 1. Okay. So this was the answer. Any questions here? No questions? Everything's clear?
सर एक क्वेश्चन था
जी असद।
सर मैंने शिफ्टिंग एक्सपेंशन और कंप्रेशन में ना मुझे थोड़ा मसला होता है कि ना मैं ऐसे करता हूँ कि अब जैसे 3 और 4 है ना
या
लाइक जी ऑफ टी में
हाँ
तो मैं 3.5 को लेता हूँ अपना रेफरेंस पॉइंट
या
और इसके दोनों साइडों पे एक्सपेंशन और कंप्रेशन
हाँ
कर इधर नहीं लेकिन वैसे मैंने असाइनमेंट में कर दिया था ऐसे
हाँ
तो उसकी वजह से सारे ये मतलब बाकी सारा सही होता है लेकिन वो एक्सपेंशन और वो काफ़ी ख़राब होते हैं तो ये इसका रेफरेंस पॉइंट आपने हमेशा ओरिजिन ही लेना होता है
yes, reference point is always zero, right? So when you're multiplying anything with anything, the reference point always origin zero रहता है ना, right?
तो लाइक उनका सेंटर से नहीं आप देखते
नहीं
रेफरेंस
सेंटर से हाफ नहीं होता. Expansion is not that. Expansion is कि अगर इसका 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 intercept 3 पे है ना, so that intercept is just going to be now at 3 times 2, and this intercept is 4, so this intercept is now going to be at 4 times 2.
सही
ठीक है. So वो expansion is you're right कि zero के origin के साथ है, यानी zero से आप expand करें उसे, दरमियान में ही इसे पकड़ के expand करते हैं.
तो वो थोड़ी ना क्लास में जो एग्जांपल्स थी वो ज़्यादातर ओरिजिन ही सेंटर बन रहा था उनका तो उसकी वजह से मुझे ना थोड़ी थी कंफ्यूजन
Okay, good. अभी अभी हो गया सही confusion.
जी सर यही था
ठीक है, that's what matters, right? Okay. Any other questions?
सर
जी.
सर इसमें हम लोग पहले जो एक्स ऑफ टी है
या
हम इसकी पहले अंदर t/2 -3 करके क्यों नहीं कर रहे
उसा कर लें, उसा भी कर सकते हैं. You want me to do that first?
नहीं सर वो मैंने उस तरह करके आ गया था लेकिन सर
उससे आंसर डिफरेंट आएगा.
मुझे लग रहा नहीं मुझे लग रहा था कि इस तरह आंसर डिफरेंट आएगा लेकिन सेम आया
हाँ, so आप वो उसके लिए अगर आप करेंगे ना तो let me just write this down. I'm not going to do it and let me just leave this for you as an exercise maybe, which is कि जी if I define, चलो let me use another notation. If I define w of t as being equal to x of t by 2, ठीक है, that's w of t. Then what is y of t as a function of w? W की मैं क्या ट्रांसफॉर्मेशन करूं कि वो y बन जाए? And turns out कि that would be w of t minus minus क्या होना चाहिए? And you can plug in things here and as you deem fit. So this should be t minus 6, right? Because I can clearly see कि if I plug in w of t which is x of t by 2, ठीक है, so if I यहाँ पे t की जगह t minus 6 होगा, right? तो यहाँ पे t की जगह t minus 6 होना चाहिए, right? So therefore this would be x of t minus 6 divided by 2, right? And which is x of t by 2 minus 3, which is indeed what I was looking for, right? So if you were doing the compression, the expansion first, तो पहले expansion कर लें, but then you have to shift by 6 seconds to the right to be able to get to what you wanted in the first place. ठीक है हमजा?
सर वो सही है मैंने जो सर इस तरह किया था u of t जो है और इसके अंदर मैंने ना t/2 -3 करके कर लिया था और मैंने इंडिविजुअली इनको डायरेक्टली प्लॉट किए थे
Okay,
और फिर मैंने मल्टीप्लाई बाय t कर दिया था
that's fine as well.
ठीक है सर
That's also good. Okay, अच्छा. This was problem 2, problem 2a. This almost everybody got right, and clearly this is not a periodic signal, right? The reason why it's not a periodic signal is because of this e raised to power minus 2 plus j pi t, and which is equal to e raised to power minus 2t times e raised to power j pi t. So this is a complex exponential, but it's not a periodic complex exponential. This is actually a decaying complex exponential, and most of you did this right. Okay? I think I don't need to spend a lot of time here. Or if somebody wants me to explain something here, just let me know.
तो इसका जो सेकंड पार्ट था -2t गया, that was not a complex exponential. I wrote दोनों parts की reasoning के second part भी इसका periodic नहीं है, first भी नहीं है, although one explanation is enough. So उसके marks कटेंगे ये अगर इसमें हमने.
So what I was looking for is this यार, minus e raised by minus 2t के बारे में argue किया नहीं. So so this thing is periodic.
Yeah.
Right? But this thing is not periodic. Because of e raised to the power minus 2t. And you're adding a periodic signal to an aperiodic signal, and the resultant is also aperiodic.
ठीक है.
All right. Any other questions here? All right. Right. So this is part B. Is part may many students faced issues, right? So there are multiple ways of doing it. I mean, the way I visualize this is just by looking at the signal, right? So this is u of minus t, and this is u of t minus 2, right? So if I draw the number line or the x-axis as a function of time here, what I observe is, okay, yeah, there's this t equals 0, and there's t equals 2. The signal before this time t equals 0 is actually e raised to power 2 plus j pi times t. And the signal after time t equals 0 is actually cosine pi by 4t. Does that make sense? I mean, I just look at the equation, and that's what the equation tells me. Okay. Any questions here? I mean, there are other ways people have done it, and they've done it correctly as well. And perhaps I can say something about that a little while later, right? So, but what I have here is here on the number line, the signal from minus infinity to plus infinity can be broken down into two parts, two non-overlapping parts, right? One part is from minus infinity all the way up to 0, and the other part is from 2 all the way up to infinity, right? So if I were taking the absolute value of this signal and integrating from minus infinity to plus infinity, what I would get is, so E infinity, it would be that. So that would be integral from minus infinity to plus infinity, x of t absolute squared dt is in fact integral from minus infinity to 0, absolute value of e raised to power 2 plus j pi times t times dt, and plus integral from 2 to infinity, and the absolute value of cosine pi by 4t squared, right? So there's a squared here, right? So some students forgot to do the squaring, right? And I see here, this is infinity, clearly, right? Why is this infinity? Anyone? Why is this energy infinity? Ji Hamza.
सर जितना मुझे लगता है, जितना मैंने किया सर, the trigonometric part of this signal, that is a periodic signal, hence its energy would be infinity. तो अगर एक part उसका infinity पे चला गया है, तो irrespective of other part, अगर वो contained bounded भी रह रहा है, तो फर्क नहीं पड़ता उस बात से.
Okay, right. So let me expand on this a little bit. So this is e raised to power 4t, right? And this is 2 to infinity 1 plus cosine pi by 2t divided by 2 times dt. Okay, I just expand this out, right? And the integral of e raised to power 4t times dt from minus infinity to 0 is actually finite. I mean, that's because this is growing exponential, but on the negative axis, it always stays finite. I mean, it starts at minus infinity at 0, and at time t equals 0, it only reaches all the way up to 1. Okay? So its area under the curve is actually finite, and you can evaluate what this is through evaluating this integral. This is finite. But this is infinite. This is infinite. And that's because of this term here. Right? Just half you're integrating from 2 to all the way up to infinity. That must be equal to infinity. And that's why this is this area under the curve is infinity. Okay? But what I dedicated more points for is evaluating the power, right? The power की definition क्या है? This is limit t going to infinity, 1 upon 2t, integral from minus infinity to plus infinity, x of t absolute squared dt. This is limit t going to infinity, 1 upon 2t, and I can split this integral from minus infinity to 0. And this is the absolute value of e raised to power 2 plus j pi times t absolute squared dt, and plus limit t going to infinity 1 upon 2t, and integral ये कहाँ से कहाँ जाएगा? This will go from 2 to infinity, right? And what are you integrating? You're integrating cosine pi by 4t and absolute squared dt. ठीक है? So what happens there? So next, this turns out to be equal to limit t going to infinity 1 upon 2t. This is integral from minus infinity to 0. This is e raised to power 4t dt, plus limit t going to infinity 1 upon 2t, integral minus infinity to plus infinity, and cosine squared theta, I use the identity cosine squared theta is 1 plus cos 2 theta divided by 2. So therefore this is half plus half times cosine pi by 2t times dt. ठीक है? Actually, sorry, this is from 2 to infinity, right? And what do we get in the first term? So this is limit t going to infinity 1 upon 2t, and this is integral, so this is e raised to power 4t divided by 4, and this is minus infinity to 0, right? And this is limit t going to infinity 1 upon 2t. I made a mistake here. Sorry, so this is minus t, and this is, sorry, my bad, right? So not all the way up to infinity, right? So you're taking the limit, and this is plus t, and this is minus t, and this is minus t. Okay, and this is half t from 2 to t plus limit t going to infinity 1 upon 2t, and this is half integral 2 to t cosine pi by 2 t dt, right? I don't need to evaluate these values because I claim यार ये पूरी की पूरी चीज है ना, ये पूरी की पूरी चीज, this is equal to 0. Why is this equal to 0? Why do you think is 0?
सर क्योंकि नेगेटिव टी की टर्म आ जाती है एक्सपोनेंशियल में, और जब लिमिट इंफिनिटी अप्रोच करती है तो वो 0 हो जाता है.
वो 0 हो जाता है. But then there's a term 1 is there as well, right? Manur?
जी सर.
So you see, एक और चीज भी तो मौजूद थी, right? This would be e raised to power minus 4 times 0 minus e raised to power minus 4t divided by 4. It turns out कि ये term भी तो है ना? So this is actually 1.
जी.
Excuse me, sir.
So एक मिनट बेटा.
वो बाहर 1/2t है ना?
Yeah. Right. So because you're dividing by 2t as well, right? In that limit as t goes to infinity, I mean this term stays finite, and therefore this ratio is equal to 0. Okay. Just give me a minute, please. right? So this goes to 0. Everybody clear on that? ठीक है? अच्छा, दूसरी जो टर्म है यहाँ पे क्या होता है? So this is t going to infinity, and this is 1 upon 2t, and this is half times t minus 2, right? And then there's this term here, limit t going to infinity, 1 upon 2t, and this is half and integral 2 to t cosine pi by 2t dt. I also claim that this term is also equal to 0, and this term is equal to 0, right? So why is this last term equal to 0? पहले ये बताएं. So why is this last
वही होगा ना, 1/2t will turn into 0, और
Yeah,
वहां
but-
पर अगर हम cos में बाकी जो cos infinity वगैरह जो भी होगा वो 0 से मल्टीप्लाई होकर 0 हो जाएगा.
लेकिन देखें, but there's an integral, that integral goes to infinity all the way, right?
The integral, but the integral is will go inside cos now. तो cos infinity भी होगा तो it will have a finite value.
Excellent.
Equivalent rate.
Right, so this
Make a
green thing
difference.
that you see here is actually always going to be finite. Okay, the area under the cosine curve is always stays finite, regardless of how many cycles you're integrating over. Because I mean, the positives always cancel with the negatives. Okay, so this area under the cosine curve is always going to be finite, and you divide by something which is an infinite value, which is 2t, and therefore this whole term goes to 0. Right. So the only thing that you're left with is this thing here. And in the limit, this goes to what? This is equal to 1 by 4. Okay? So the answer to this is 1 by 4.
Yeah, सर ये जब आपने स्क्वायर किया सारी चीजों को, ये किस तरह किया था? It actually takes us a lot of time. मैंने ये सिर्फ ये स्क्वायर वाला पार्ट कर देना,
कौन सा
और then जब स्क्वायर करते हैं स्टार्ट में
सिग्नल
e raised to power 40, how did you turn it into e raised to power 40 directly?
How did I turn it into 40 directly?
Yes.
Oh, okay. ठीक है.
ये पार्ट इसी पार्ट में मेन टाइम लगता है.
इसकी बात करें आप, right? Tala?
Yes, sir.
Right. So how do I get e raised to power 2 plus j pi t absolute squared? How is that equal to e raised to power 40? Is that what you're saying?
Yeah.
Okay. Okay, good. Right. So here's how. You see, if I ask you to do this, e raised to power t 2 plus j pi t absolute squared, because there were some people who expand this into Euler's identity, वो cosine में ले गए और फिर real part भी कर लिया, फिर imaginary part कर लिया, और फिर रियल पार्ट इकट्ठे किए, फिर इमेजिनरी पार्ट इकट्ठे किए, फिर उनको स्क्वायर किया, फिर ऐड किया, फिर स्क्वायर रूट लिया, फिर स्क्वायर कर दिया दोबारा से. I mean, there were some people who did that. That's a very, very long route, right? But right, I see from here, yeah, this is equal to e raised to power 2t times e raised to power j pi t absolute squared, right? Right? Absolute of multiplication of two complex numbers is equal to the absolute value of each one of the complex numbers multiplied with each other. Right? Is that clear? यानी मैं अगर ये कहूँ यार a है और times b है, इनके मैं absolute value चाहता हूँ आप, right? So this is equal to the absolute value of a times the absolute value of b, right? I mean, that's complex numbers, right? What happened here? Right. Is that clear, Thala? I mean, if I multiply.
Yes, sir. Yes, I get it.
ठीक है. अच्छा. अब इसका मतलब ये है कि this is equal to the absolute value of e raised to power 2t squared times absolute value of e raised to power j pi t absolute squared. Right?
Yeah, यहाँ पे क्या question है? e raised to power j pi t का square, how is it equal to 1?
E raised to power j pi t squared का 1.
J pi.
Yeah, so this is from Euler's identity, right?
That is j square.
Right? Because complex exponentials always have periodic complex exponentials always have an absolute value of 1. That's something we know. Why is it 1?
ठीक है
Because this is cosine pi t squared
क्या है cosine?
plus sine squared pi t, right? This is equal, and this is always equal to 1. उसका रेडियस हमेशा 1 होता है जहां मर्जी सर्कल पे. I mean that's a circle, right, of unit radius. So that's why this is equal to 1, and therefore this is equal to e raised to power 4t. Is that clear, Talha?
जी ठीक है सर, ठीक है.
Hamza?
सर मैंने ये पूछना कि आई रेड इट समवेयर, आपके साथ मैथ रिव्यू में मैंने देखा था कि अगर आपने स्क्वायर निकालना हो इसका तो सर आप इसका कॉन्जुगेट ऑफ द गिवन एक्सपोनेंशियल उसको इससे मल्टीप्लाई कर देते हो. सर वो क्या चीज़ थी? मे बी आई मिक्स दैट अप इन द एग्जाम, क्योंकि मुझे इसमें भी काफ़ी टाइम लग गया था.
उसमें भी आप उस तरह कर लें, राइट. सो अगर मैं इसके कॉन्जुगेट से मल्टीप्लाई कर दूं, राइट, सो e raised to power 2 plus j pi t times e raised to power 2 minus j pi t. That will be the conjugate of that.
Yes sir.
Right? इसमें क्या होगा? So this would be e raised to power 4t plus j pi t minus j pi t, which cancels, which is e raised to power 4t. इसका कर लें. Right? So what I'm getting a sense of is, I mean, there's some familiarity that you need with complex numbers, perhaps.
Sir, क्योंकि पहले we
Yes, sir.
just did complex numbers in modern physics once,
Yeah.
and that wasn't उसकी application इतनी ज़्यादा थी. It was basic complex numbers और उसके modulus वगैरह निकालना. I think so. Circuits 2 and signals is the first time actually for me जिसके अंदर इतनी direct like इसकी application आ रही complex numbers की. तो इससे पहले इतनी practice की नहीं हुई. Only that one assignment जो आपने करवाई थी, ठीक है, और उसके जितने पार्ट्स थे तो उतनी प्रैक्टिस तो है, लेकिन अगर आप थोड़ा सा आउट ऑफ स्कोप होते हैं तो इट टेक्स सम टाइम टू कैच अप टू दैट, अगर मैं अपनी
Yes,
पर्सनल
sir.
बात करूं तो.
Okay. All right. Telling, so let's, I mean, that catching up, because this is going to come up not just in this course, I mean, lots of other courses from here on. खासकर पे कॉम सिस्टम में जब जाएंगे तो I mean, let's take this opportunity to train ourselves in something which seems foreign maybe. लेकिन hopefully, I mean, with time, this will not seem so foreign. Okay? Or otherwise, we're here to help you. So this is either way you do it, right? There are multiple ways you can do it. अगर आप इसको उस तरह करना चाहते हैं, इसको real और imagine भी कर लें, उस तरह भी कर लें. And people have done that and gotten to the right result, by the way. But it's just that it takes longer. ठीक है? अच्छा. Other questions?
सर.
जी हमजा.
सर आपने दोनों जो फंक्शंस हैं उनको आपने मॉड करके स्क्वायर किया.
या.
तो सर इस तरह जो कॉस का जो फंक्शन है वो सारा पॉजिटिव में नहीं चला जाएगा?
हाँ बिल्कुल चला जाएगा.
तो उससे फिर आपने कहा कि कॉस का जो इंटीग्रल है वो एंड पे 0 हो जाता है, इसलिए उनके जो नेगेटिव पार्ट है वो कैंसिल आउट विद द पॉजिटिव पार्ट.
Okay,
तो
good.
नेगेटिव पार्ट तो फिर इस तरह होगा नहीं.
राइट. एक्सेलेंट क्वेश्चन हमजा. देखें जब वो स्क्वायर्ड होता है ना, राइट, तो आई एग्री विद यू कि दिट विल ऑलवेज स्टे पॉजिटिव, राइट. सो हमने क्या किया था, इसको स्क्वायर किया था. एक्सेलेंट. राइट. सो वी चेक कि जी कोसाइन पाई बाय 4 t को एब्सोल्यूट स्क्वायर लेनी है, राइट. एंड व्हेन यू स्क्वायर इट, एंड बिकॉज दिस इज रियल, सो देयरफॉर दिस विल ऑलवेज बी इक्वल टू cosine squared pi by 40, because this is real तो बस सिर्फ स्क्वायरिंग करनी है. एंड यस आई एग्री कि दिस विल ऑलवेज स्टे पॉजिटिव. लेकिन इसके बाद मैंने किया क्या था, आई यूज अ ट्रिग्नोमेट्रिक आइडेंटिटी व्हिच वाज व्हाट, व्हिच वाज कि cosine square theta is 1 plus cosine 2 theta divided by 2, right? So this is 1 plus cosine pi by 2 t divided by 2, right? And you can actually verify that this always stays greater than 0. हमजा, does this, I mean, can you see कि यार ये जो चीज़ है ये हमेशा 0 से बड़ी होती है. Is that clear? क्योंकि कोसाइन पाई बाई 2 -1 और +1 के दरमियान में ना, उसको आपने +1 से शिफ्ट कर दिया, the minimum value is always going to be 0.
ठीक है.
And the maximum value here is going to be 2 of the numerator, and you divide by 2, so it's always going to stay between 0 and 1.
ठीक है सर.
ठीक है?
सर
अच्छा.
कोई ये आइडेंटिटी
अब इसको इंटीग्रेट करें, राइट? अब इसको इंटीग्रेट करें,
जी.
राइट? तो इसका जो फर्स्ट टर्म है वो क्योंकि पॉजिटिव है तो वो इन्फिनिटी की तरफ डाइवर्ज करेगी, लेकिन जो सेकंड टर्म है वो डाइवर्ज नहीं करेगी, वो जो है विल ऑलवेज स्टे फाइनाइट. सो दैट्स व्हाट आई सेड, राइट? तो जब मैं इंटीग्रेट कर रहा था वो कोसाइन स्क्वायर्ड को नहीं कर रहा था, मैं कोसाइन को इंटीग्रेट कर रहा था. अब बताइए हमजा, यू हैव अ क्वेश्चन और सम अदर पॉइंट?
जी सर. सर ये तो पार्ट समझ आ गया सर, लेकिन हम ऐसा कर सकते हैं ये आइडेंटिटी यूज ना किए बगैर हम सॉल्व करें?
नहीं. सो देखें, कोसाइन स्क्वायर्ड का इंटीग्रल लेने के लिए यू वुड हैव टू यूज दिस आइडेंटिटी. आई मीन दैट्स द इजीएस्ट वे टू डू इट.
ठीक है. मतलब कोई ना कोई आइडेंटिटी लगानी पड़ेगी, नहीं तो वो फिर इंटीग्रेशन आई थिंक बाय पार्ट्स ये हो जाता है.
Yeah, so integration, I have to think about if you don't use this identity, would you be able to integrate this out, cosine squared? Perhaps we chain rule या type चीज लगाएं. I mean, that would get very long.
ठीक है सर.
लेकिन this is the easiest way.
सही सर.
ठीक है. So the area under cosine, yes, it's finite, but the area under a cosine squared from -infinity to +infinity, that is infinite. ठीक है, because of the fact that you mentioned, it always stays positive. तो अगर आप infinity -infinity से +infinity integrate करें, तो that area will always turn out to be infinite because you're just adding things up. ठीक है, कोई cancel नहीं हो रही कोई भी चीज. Right. Any other questions before we move to part 3, question 3? Okay. So I mean, this is just what you had to do. Okay, just verify whether the system is time invariant or not time invariant, right? So I'd say here, if x1 of t is the input, the output turns out to be y1 of t, which is integral from -infinity to t x of tau d tau, right? And then you say, Kiji, let me put in another value, another input x2 of t, which is actually equal to x1 of t minus t naught, right? Then the output y2 that I'm going to get is integral from -infinity of t to t of the input. And the input was x2 of tau. But x2 of tau is just x1 of tau minus t naught d tau. Okay? And then if this was a time invariant system, for the system to be time invariant, y1 of t or y2 of t should equal y1 of t minus t naught. So अभी मैं यही क्वेश्चन अभी ग्रेड कर रहा था. For example, Zain, I think you did this and you just wrote the statement, or then you said कि जी it's clear कि जी why this condition was not satisfied. And there are some others who wrote this as well. Okay, they got to this point, they applied the correct definition of time invariance and say, for this system to be time invariant, the y2 of t should actually be equal to y1 of t minus t naught. But since this is not so, I mean, I look at the equation and say, ye nahi hai, so it's not time invariant. In fact, it turns out that this condition is satisfied because if you just use a change of variables, you'd see that y2 of t is -infinity to t x1 of tau minus t naught t tau, and I say that you let s equals tau minus t naught, then y2 of t is equal to -infinity, and if you do the change of variables thingy, right? So this turns out to be equal to S. Actually, sorry. So this turns out to be T minus T naught. So let me pull this up. So that I have more space. Right. So this is equal to minus infinity to T minus T naught. And this is x1 of S ds. And this indeed is equal to y1 of T minus T naught. So the system is time invariant. Is that clear? जी हमजा.
जी सर, मैंने आपसे ये पूछा सर, if you can go back to the question, मेरे स्टेटमेंट से मैं चीज पूछनी थी.
Yeah.
सर यहाँ पे जब आपको वो कहता है कि यू हैव टू प्लग इट इन, आपने जब इसकी टाइम इनवेरियंस चेक करनी होती है तो सर आप उसके इनपुट में प्लग करते हो. सर यहाँ पे जो टॉ है सर, टॉ इज जस्ट द वेरिएबल ऑफ इंटीग्रेशन. सर वेयर एज जो इनपुट आप करते हो सर, इनपुट आप टी के ऊपर नहीं करते. सर शुडंट द वैल्यू बी प्लग्ड इन इनटू द लिमिट्स ऑफ इंटीग्रेशन, क्योंकि सर दैट इज द पॉइंट जब इंटीग्रेट होके जब चीज प्लग होगी सर वो वहीं से प्लग होगी. तो जो भी आप चेंज करोगे वो टॉ में तो चेंज नहीं आएगा ना, टॉ तो सिर्फ उसके अबाउट इंटीग्रेट हो रहा है जितनी मेरी अंडरस्टैंडिंग है. तो इज दैट द करेक्ट लॉजिक?
नहीं हमजा ये देखिए, ये जो टी है ना, ये जो टी है इंटीग्रेशन में, वो ये वाला टी है.
अच्छा ठीक है.
Right? So you're evaluating the output at time t, and that time t appears in the limits of the integral, right? But what you're integrating is a signal, right? Which is x of t, and where the time axis है, time axis में integrate कहाँ से कहाँ तक करें? Minus infinity से all the way up to whatever time t of the output was.
ठीक है सर.
ठीक है. तो अब अगर मैं इसको यहाँ पे वही लॉजिक इस्तेमाल करूँ कि वेरिएबल्स क्या है, तो ऐसे कि जी इफ x2 of t is the input, right, I should have x2 of tau here, right?
Corresponding as a corresponding signal.
Yeah, because that's the input. Now my input is no longer x1 of t but rather x2 of t.
All right.
So I just replace x1 with x2, right?
ठीक है सर.
Yeah, whatever the input, just integrate that from minus infinity to t. That's what the system does.
ठीक है.
And then I observe कि यार x2 of t is equal to x1 of t minus t naught, and therefore x2 of tau must be equal to x1 of tau minus t naught, because I just replace tau with tau minus t naught.
सर मुझे लाइक बात मुझे समझ आ गई है कि यू आर जस्ट प्लेइंग अराउंड विद द वेरिएबल्स हियर. लेकिन सर मुझे the variable tau, doesn't that just represent, it's just kind of a dummy variable जिसके ऊपर आप इंटीग्रेशन कर रहे हो? like does it really matter कि like input तो आपका t ही रहेगा ना? you
लेकिन देखें उसमें जो डमी वेरिएबल है that is intricately that's indeed linked with time t, the variable t as well, because a dummy variable है that has to be integrated from minus infinity all the way up to what point? All the way up to t. ठीक है. So there's a link there.
ठीक है.
ठीक है. अगर माइनस इन्फिनिटी से ये t तक ना होता, ये कहीं और जगह तक होता, तो फिर then the system would have been different. It actually would not have been time invariant then.
सर तो मेरा पॉइंट यहाँ पे ये है कि जब भी आप यू आर शिफ्टिंग द इनपुट, लाइक आपका जो टाइम लाइक इनपुट कर रहे हो आप उसको, यू आर शिफ्टिंग दैट. तो सर जो आपकी लिमिट है इंटीग्रेशन की, आपने मुझे बताया वो माइनस इन्फिनिटी से टी तक जा रही है सर. तो आरंट यू चेंजिंग दैट पर्टिकुलर लिमिट, लाइक वो जो राइट वाला काइंड ऑफ काउंटर है या जो भी बार है आप उसको नहीं मूव कर रहे? सो शुडंट द लिमिट बी आल्सो अफेक्टेड बिकॉज ऑफ दैट?
नो, सो लिमिट इज नॉट इसलिए नहीं अफेक्टेड क्योंकि आप जो है आउटपुट में अभी शिफ्ट आपने कोई नहीं दिया, राइट? आपने सिर्फ इनपुट पे शिफ्ट दिया है.
ठीक है.
और आप कह रहे हैं कि इनपुट पे शिफ्ट देने के बाद जो एक और नई इनपुट है, और इन अदर वर्ड्स कि x1 में मैं शिफ्ट देता हूं एंड दैट इज अ न्यू इनपुट टू द सिस्टम.
ठीक है.
ठीक है. सो दैट इज अ न्यू इनपुट टू द सिस्टम, एंड दैट न्यू इनपुट टू द सिस्टम इज जस्ट x2, which is a shifted version of what you had originally.
ठीक हो गया सर,
ठीक
ठीक
है। इसको in other words, so I'll try to cook up some example to explain this visually as well, perhaps sometime. Okay, why is this system time invariant? Okay, so I mean, if I think of this off the top of my head, I may mess it up. So perhaps I'll prepare an example which is easy to understand and then visually explain it. Okay.
all right sir.
Right. So let me just do the other ones quickly, right? So this is part B, which is determine the output of the system when the input is x of t e raised to power 2t. So यहाँ पे कोई convolution नहीं करनी थी, right? All you had to do was just determine what the output is. Y of t is minus infinity all the way up to t e raised to power minus 2 tau u of minus tau d tau, right? इसको किस तरह इंटीग्रेट करूँ मैं? सो अभी तक जो मैंने जितने भी ग्रेड किए हैं उसमें अभी तक कोई I mean there are only 3 or 4 I've done, right? The question number 3 जो है
माइनस इन्फिनिटी से 0 हो जाएगी इसकी लिमिट,
राइट. सो जी ताला दोबारा से कहिएगा प्लीज.
माइनस इन्फिनिटी टू 0 और u of t खत्म हो जाएगा, ठीक है, हम u of t को यूनिट में लगाएं.
राइट. सो आई मीन व्हाट डज द सिग्नल लुक लाइक? सबसे पहले ये बात करते हैं, राइट? So if I were to visualize a signal as a function of tau, right? So this is what the signal looks like, right? And this is, if this is tau, this is equal to 0, right? And this height would be equal to 1. And what is the system really doing? The system is integrating or finding the area under the curve from minus infinity to t. G, Hamza? कौन बोला है? दानियाल बोला है. यस
सर ये तो डिकेइंग फंक्शन नहीं है e की पावर minus 2t.
Oh, sorry, that's not a right indicator, right? So this is a decaying function. Yes, so this is decaying, लेकिन u of minus t की वजह से this falls down, ठीक है? And the height is 1. Thank you. ठीक है, so this is an exponential decay. Okay, so you're finding the area under the curve, right? From minus infinity to t. What is the area under the curve? किसा करेंगे? मैंने
सर ये 0 तक,
जी दानियाल, go ahead.
0 तक करेंगे और सिर्फ e raised power minus 2t का इंटीग्रल.
All right, लेकिन what if t is less than 0? So this is a common mistake that many have done. Right, what you just said, Daniel, right? Because t could both be greater than 0 or be less than 0. So if t, for example, was less than 0, right? If this was t, right, then you would have been actually evaluating this curve, this area. Right? And what would this have been equal to? This would have been equal to, so for t is less than 0, y of t would have been integral from minus infinity to t, just e raised to power minus 2 tau d tau. And this would have been minus half e raised to power minus 2 tau.
क्वेश्चन में 2t है,
क्वेश्चन में 2t,
क्वेश्चन जो ऊपर x of t is equal to e raised to power 2t.
Yeah. So my bad. So this is 2, and this, of course, जो मैंने पहले ड्रॉ किया था वो सही था, right? This is a growing exponential. So this is a growing exponential, right? And this is the area here integrating over. ये diverge कर जाता अगर 8 minus होता वैसे, by the way, right? So this is 2 tau, this is 2 tau, this is this, and this is minus infinity, right? What does this evaluate to? This is half e raised to power 2t. But this is only the case when t is less than 0. For t is greater than 0, what happens? That's where this is minus infinity, because if t is, let's say, somewhere here, so when you're finding the area in the curve, all you need to do is just integrate from minus infinity all the way up to 0, right? So this is 0, and this is half e raised to power 2 tau d tau. It turns out this is equal to half. Okay, so your y of t is equal to half e raised to power 2t for all values of t which are less than 0, and is equal to half for all values of t which are greater than 0, right? Hamza, ये आपका हाथ खड़ा हुआ है. Is this you have a question? Or was
सर
this?
नहीं सर, मैंने ये पूछना है कि ये t for greater than equal to 0, सर ये हाफ कैसा है, ये बात दोबारा बता देंगे?
So this is sorry, यहाँ पे half नहीं है, right? So this is half e raised to power 2 tau minus infinity to 0. ठीक है, this thing evaluated, this is half, and this thing evaluated minus infinity is 0.
और ठीक है सर, आई गेट इट. वो आपने हाफ लिखा हुआ था, मुझे लगता है
half,
उसको
okay.
हम क्यों यूज करें. ठीक है
And
सर.
there's another way, because there's a continuity कि उसकी वजह से अगर यहाँ पे you just plug in t equals 0, that you get the answer. ठीक है, which is just half.
सर यहाँ पे अगर हम लोग इसको देखें, सो फॉर t इज ग्रेटर देन 0, आपके ग्राफ आपका ग्राफ 0 है, लाइक ग्राफ की वैल्यू 0 पर, तो सर एरिया अंडर ग्राफ भी 0 ही नहीं होगा?
नहीं,
क्योंकि सडन फॉल आ रहा है उस पॉइंट के ऊपर.
एरिया अंडर द ग्राफ, देखें एरिया कहाँ से स्टार्ट होता है कैलकुलेट करना, फ्रॉम माइनस इन्फिनिटी.
जी सर.
राइट, माइनस इन्फिनिटी चलते आ रहे हैं, और as you keep on increasing time, right, time t, the area is going to keep on increasing.
सर मैं 0 से आगे बात कर रहा था.
0 से आगे क्या होगा? 0 से आगे एरिया क्या रहेगा? कांस्टेंट रहेगा ना.
जी सर, बिल्कुल ऐसे ही है.
whatever t is, ये वाला हिस्सा तो हमेशा रहेगा इसके अंदर.
जी सर.
And that's not 0, that's half. So as you keep on increasing t greater than 0, the area stays constant, and the stays constant is being equal to half.
अच्छा, ठीक हो गया.
यहाँ पे बहुत सारे लोगों ने वैसे 0 लिखा हुआ है, बहुत सारे जितनों को मैंने चेक किया उसमें से कुछ लोगों ने. Okay, and finally this was perhaps the easiest.
सर पिछले वाले से एक सवाल था.
जी go ahead. जी हमजा.
सर जो t is less than 0 है सर, इसकी लिमिट्स t to 0 क्यों नहीं होंगी?
Because the signal has a u of minus t, right? ठीक है, is t to minus so has a u of minus t. इसका मतलब this only exists on the negative axis, right?
ठीक है.
If it only exists on the negative axis, that means you're integrating from minus infinity all the way up to t.
सर लेकिन वो तो सर मुझे पार्ट समझ आया कि नेगेटिव एक्सिस पे होगा सारा हमारा फंक्शन. लेकिन सर 0 to t नहीं होना चाहिए, मतलब अगर t की नेगेटिव वैल्यू भी है, मतलब अगर t की वैल्यू -5 है तो 0 -5 to 0.
देखें इस सिस्टम को देखें, इस फंक्शन को देखें क्या कर रहा है. ये कर रहा है क्या था कि जी माइनस इन्फिनिटी से t तक सिस्टम ऐसा है कि जो माइनस इन्फिनिटी से स्टार्ट करता है, starts computing the area in the curve all the way up to time t, where this time t, small t, is a variable that could be anywhere, right? अब लेकिन सिस्टम आपको कह रहा है कि यार सिस्टम ऐसा है कि जो माइनस इन्फिनिटी से स्टार्ट करता है और t तक जाता है.
ठीक है सर, ठीक है.
राइट, तो अब माइनस इन्फिनिटी से t तक तो सिस्टम कह रहा है आपको जाने का, 0 से t नहीं कह रहा.
ठीक है सर.
और फिर जब t आप बढ़ाते जाते हैं 0 से ऊपर जाते हैं, तो इट टर्न्स आउट कि 0 से ऊपर सिग्नल रिजाइड ही नहीं करता, और 0 से ऊपर जो सिग्नल है टाइम t 0 से ऊपर जो है वो टाउ 0 से ग्रेटर व्हेन हियर द सिग्नल इज 0, राइट. So you're integrating from minus infinity up to this point, that's just equal to the area all the way up to यहाँ पे जाके स्टॉप कर देगा। इससे बाकी आगे सारा जीरो की कंट्रीब्यूशन, एरिया की कंट्रीब्यूशन जीरो है। ठीक है, does that make sense?
जी जी सर, ठीक है।
Right. And any other questions from this? Right. So y of t is this, right? और impulse response क्या होता है? Impulse response is the output of the system that you get when the input is a delta function. When x of t is equal to delta of t, y of t of the system is actually known as something called the impulse response. Therefore, h of t is equal to 3 times integral from t minus 1 all the way up to t delta tau minus 4 t tau. Okay? So this is the impulse response. All you need to do next is to just simplify what this equates to, right? So if I just now visualize what this equates to, I see here, if this is the tau axis, I mean, what does this equation telling you? If this is tau axis, it tells you that there is an impulse residing at tau equals 4. और इंटीग्रेट आप कहां से कहां तक करें? इंटीग्रेट, you're integrating from t minus 1 to t, and this is a window that you're sliding. ठीक है, y of t, as you're evaluating y of t from for time going from minus infinity plus infinity, that means ये window है और ये स्लाइड करती जा रही है, लेकिन इसकी लोअर एंड और अपर एंड में फर्क हमेशा 1 सेकेंड का रहता है, राइट? Now, for this particular depiction that you see on your screen, right, where t is less than 4, what is this area under the curve going to be equal to? 0. Excellent, Daniel, right? And when is this area under the curve going to be non-zero? Right? So as you start pulling this up, तो जब t इधर पहुंच जाए, let me use what color, right? So here, जब t इधर हो जाए, लेकिन t minus 1 has to be less than 4. That's where 4 is going to be inside the integration limits, right? So this integral is going to be equal to is going to be non-zero when t minus 1 is less than 4 and t is greater than 4, right? That means कि ये t इधर पड़ा हुआ है और t minus 1 इधर पड़ा हुआ है. In other words, t और t minus 1 के दरमियान में 4 है. That's what this means, right? And this implies or this implies t is less than 5 and this implies t is greater than 4. That means कि 4 is less than t is less than 5. So from this argument, I can conclude that h of t is equal to 3 as long as 4 is less than t is less than 5 and is 0 otherwise. Right? And what kind of a signal is this? This is h of t is 3 times u of t minus 4 minus u of t minus 5. Okay? So that's the solution. Questions?
सर ये जो आपने अपने राइट पे लिखा हुआ है टी और 4 और 5, इसका मतलब तो ये नहीं है कि टी 4 से बड़ा है, मतलब 4 से राइट पे है?
या लेकिन 5 से छोटा होना चाहिए.
अच्छा, टी माइनस 1 उसमें आ जाएगा. हाँ,
क्योंकि टी 4 से बड़ा होने का मतलब ये भी तो हो सकता है ना कि टी 8 हो फॉर एग्जाम्पल.
जी जी,
राइट? अगर टी 8 है तो टी माइनस 1 7 पे पड़ा हुआ है, राइट?
जी जी.
That means you're integrating from 7 to 8, but 4 is not between 7 to 8. So the answer is going to be 0 there. Okay, so you have to have two conditions therefore, which is that t must be greater than 4 and t minus 1 should be less than 4. Right? So ये होनी चाहिए, यहाँ पे होना चाहिए.
सर, और दूसरी बात, इसका आंसर जो है, फाइनल आंसर तो इसका एक एरिया नहीं होना चाहिए क्योंकि हम इंटीग्रेशन कर रहे हैं.
नहीं, so you were okay. So area ही है by the way, right? So this is the area under the curve.
पीस वाइज करके क्यों लिख रहे हैं हम एक तरफ लिख सकते हैं मतलब 3 है।
हाँ, फिर से बताइएगा दानियाल।
सर हम उसको पीस वाइज करके क्यों लिख रहे हैं? एरिया तो हम एक बस लिख देते हैं ना कि इस फंक्शन का एरिया इतना है, नहीं लिख कि कहाँ से कहाँ तक।
इसलिए क्योंकि जो एरिया है ना वो इज अ फंक्शन ऑफ टी, राइट? सो एज टी चेंजेस द एरिया चेंजेस एज वेल, राइट? ये फंक्शन इधर का है टी का, राइट? हैड दिस बीन अ कांस्टेंट दानियाल, फॉर एग्जांपल if I said कि let's say कि t is equal to some number, right? This h of t would have also turned out to be some number, right? But h of t is a signal, therefore there's an independent variable t. As I keep on changing t, I will get a different area under the curve. Does that make sense?
Yes sir.
And that's why it's a signal, right? So if I were to, for example, plot this signal, this area in the curve out, right? So this is t, and h of t would look something like this कि ये है और फिर ये 3 पे जाता है, फिर ये जाता है और फिर ये जाता है, right? So where this is 4 and this is 5. This is h of t, which is the area under the curve. What that means is कि if I evaluate that area under the curve for any value of t, for example here, that area will be 0. Any value here, that area will be 0. Any value here, that area will be 0. Any value here, the area is going to be equal to 3. Any value here, the area is going to be equal to 3, and so on and so forth. Any value between 4 and 5, the area is going to be equal to 3. For all values of the area greater than 5, for all values of t greater than 5, this area will be 0 once again. ठीक है? तो एक वेरिएबल है जो आप बस सब चेंज करें. Does that make sense, Daniel?
Yes sir. Yes sir. Thank you.
Okay. Any other questions? So I mean, for the exams that I graded, I mean, there were some who were almost there. I mean, there's one person who got it exactly right out of 5 or 6 जो मैंने grade किया. Okay, so I most likely you will I will have graded them exams by tomorrow, inshallah. Any questions about the solution here?